Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Sayyid Hamdan Hassan.
And I am Mohammad Ahmed Qazi.
We both are the students of grade 8, representing the Science Society of our school. Today, we are going to present a working model of a line-following robot. Now, what is a line? A line consists of two or more linear coordinates which represent a certain distance. And now, a question for the audience. What comes to your mind when you hear the word robot? Anyone?
Machine is like a robot.
All right. Anyone else?
Self-controlling machine.
All right.
Artificial intelligence.
All right. Yeah.
Jazakallah. A robot is a machine which can perform complex actions that have been programmed into its microcontroller using a computer. Similarly, in our line following robot, we have programmed it to follow a black line, and for that purpose, it uses infrared technology. The infrared technology uses a sensor which has two components. The first component is a photodiode, and the second one is an infrared ray transmitter. The infrared ray transmitter emits infrared radiation which reflects off the surface below the sensors. The photodiode then reads the values caused by the reflection, and if those values are low, it determines that the surface below them is of a dark color or of a black color. And because the dark colors reflect lesser light than the lighter colors. That is how the infrared technology differentiates between black and white color.
And now let's talk about the components used in the LFR, the line following robot. It uses a microcontroller named Arduino. It uses IR sensors, gear motors, jumper wires, and a motor driver. Now, the microcontroller we've used in the LFR, the line following robot, we can program it according to our needs, and it can control the robot and the rest of the components used in the LFR, the line following robot, according to the instructions given in the code by the user. Then it uses IR sensors, infrared sensors. As Muhammad Ahmad has previously explained about the infrared technology, so let me tell you, there are two types of infrared sensors, the infrared digital sensor and the infrared analog sensor. So, the infrared digital sensor is preferred more over the infrared analog sensor, as it is more precise in following the black line. Then it uses a motor driver. A motor driver receives the data from the microcontroller named Arduino and then amplifies the current according to the instructions given by the microcontroller. Then it uses gear motors to move the robot along the black line and uses jumper wires to connect all the components used in the LFR, the line following robot. And now that we've learned about all the components used in the LFR, the line following robot, now it would be much easier to understand the mechanism of the robot.
In our robot, we have used two of the IR sensors. When those sensors detect a black surface below them, they send digital signals to the microcontroller. The microcontroller then processes the data given to it and sends electronic current to the motor driver. The motor driver then amplifies the electronic current according to the instructions given to it by the microcontroller, which is Arduino Uno. The amplified current is then transferred to the gear motors, which begin to rotate in order to follow the black line. And that gives us a working model of the line following robot.
And now, as everything has some potential applications, let's talk about the applications of the LFR, the line following robot. First of all, we can use it in the industrial sector, as the industrial sector in the most of the work is of transportation of goods in the perimeter of the work area. So rather than using huge machinery for that purpose, we can use the LFR, the line following robot, as it only follows a black path and there is no need to supervise it, because there is a particular black path and it will follow it and take the products to the desired place. Secondly, we can use it in malls, museums and amusement parks as a tourist guide, because it moves along a black path and it can take the tourist along the museum to see everything. And now, moving on to the demonstration.
So light.
Lights. 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 The blue lights on. And now, as you're seeing, this robot is following the black line. And this is the robot that we've made called the line following robot. And we have calibrated it in such a way that it only follows a black path. As you can see that it only follows a black particular path and doesn't go astray. Due to the least reflection values. And now, moving on towards taking the question from the audience.
What are the obstacles in adapting this technology in real world?
All right. So actually there are not that many obstacles, but there is one. There is an obstacle, and the problem is only of the sensitivity. As you can see over here, we've used sensitive sensors and the microcontroller. So these parts are sensitive. So we'll have to work on the sensitivity of the robot, as it can't avoid getting into harsh environment. So it can't work over there.
Is the microcontroller same as the microprocessor we have in our CPU?
No, actually there is a difference. And the difference is that the microprocessor we have in our CPU, it doesn't have any sort of built-in RAM or ROM. The microcontroller.
What is the difference between analog and digital IR sensor?
Alright. So, as I previously explained about the IR technology, so there are two types of infrared sensor, the infrared analog sensor and the infrared digital sensor. So, the infrared digital sensor is preferred more over the infrared analog sensor, as it is more precise in following the black line, because it only follows two colors at a time, black and white. It doesn't go astray on any sort of other colors, and it only sends the data in 0 and 1. But opposite is with the analog sensor. It can sense too many colors at one time. Rather than only following the black path, it will go astray on other lines. If there's a black line and there's an orange line, it will get confused where to go, because it can sense all the colors at a time.
What is the difference between visible and infrared spectrum?
The difference between these two spectrums, the Vibgyor spectrum and the infrared spectrum, is only of wavelengths. The infrared spectrum is of a wavelength of 700 nanometers to 1 millimeter, and the spectrum of Vibgyor has a wavelength between 400 to 700 nanometers. The only difference and the main difference is of wavelengths.
What is the difference between, between IR detector and our eyes?
The difference between these two spectrums, the Vibgyor spectrum, is of a wavelength of 700 nanometers to 1 millimeter, and the infrared spectrum of Vibgyor has a wavelength between 400 to 700 nanometers. The only difference and the main difference is of wavelengths.
What is the difference between IR detector and our eyes?
As I have told you, the difference between the Vibgyor spectrum and the IR spectrum, our eyes detect only the wavelengths of between 400 to 700 nanometers. That is why we can see the Vibgyor spectrum, but we cannot see the IR spectrum with our eyes. The infrared sensors can sense the wavelengths of 700 to 1 millimeter nanometers. The difference between our eyes and the infrared sensors is only of the difference in sensitivity of wavelengths.
Jazakallah.